So for the rest of the problems, we're really not doing anything new. We're just taking some of the old concepts we learned in Chapter 13 and applying them to KSP problems. So we are going to play the game Will a Solid Form. So when you add sugar to water, it dissolves, right? And if you keep adding sugar, it'll dissolve. And you keep adding sugar, it'll dissolve. And you keep adding, and you keep adding, and keep adding, and eventually your water will not absorb any more or dissolve any more sugar. It'll start to fall to the bottom of the solution. We say the solution is saturated, okay? Well, it's the same thing when you add anything. We say that lead chloride is insoluble, right? But a very small amount of it will dissolve. Well, what if I only add a very small amount? If the amount I add is so small, will all of my lead chloride dissolve? And so that's what we're going to do here and play the game Will a Solid Form. So I'm going to add a very small amount of lead chloride, 0.525 grams, and I'm going to put it in 250 milliliters of water. So the first thing I'm going to have to do is convert this to molarity, okay? So my milliliters becomes liters, and 278 grams of lead chloride gives me 1 mole. So my molarity is going to be 0.00755 molar of the lead chloride. Now, remember there are 2 chlorines, so that means the chloride is going to have a concentration twice as big. Okay? So, will a precipitate form on the bottom of your beaker? This is where we're going to calculate Q. Q, remember, is when you're calculating your initial concentrations and not the equilibrium. If Q is greater than K, precipitate forms. If Q is less than K, no precipitate. If Q is equal to K, it means you are just at the saturation point, meaning that there is no solid, but the very teeny little bit more you add, you are going to get solid. Now, it's just K. We call it KSP because we're dealing with solubility, but it's the same old K we learned in Chapter 13. So, the KSP in this one is 1.6 times 10 to the negative 5th. All right. So let's go ahead and calculate Q. So Q is going to be products over reactants. We don't include solids. We only include the things that are aqueous. So lead over chlorine. Don't forget the square of the chlorine. All right, like I did in the last video. So let's plug in our initial concentrations. Calculate Q. And I get 1.72 times 10 to the negative 6th. Well, is Q greater than KSP? Yes, it is. So precipitate forms. Okay? And in the very first video, we calculated what the maximum concentrations of those two things, the lead ions and the chloride ions, are when it's just that, when it's only lead chloride and water. When you only have lead chloride and water, and that's the only thing you add, the maximum concentrations are 0.0165 molar for lead. No. Yeah, we'll just leave it right there. We don't need to complicate it anymore. If your Q is greater than your KSP, oh, for goodness sakes. Okay, so yes, I'm extremely embarrassed because I'm not paying attention. This is to the -5th, this is to the -6th. All right? Yes, that's embarrassing. Hopefully you watch the video to the end. So that means no precipitate. And that is why I started realizing my mistake when I said we calculated the maximum concentrations in the very first video. What is the maximum concentration of lead in the first video? What is the maximum concentration of the chloride in the first video? So if you're only putting lead into water, that's it, nothing else. That is going to be the maximum concentration of your lead ions. That's going to be the maximum concentration of your chloride ions. Well, compare that to these numbers up here. Both of those numbers are below the maximum concentrations. Therefore, you're not going to get a precipitate. Plus, 10 to the -6th is smaller than 10 to the -5th. Even a first-year algebra student knows that, but not your chemistry teacher.